Today I'll show you the setup, the FPV setup and the autopilot setup, which we fly in the RV jet in most of our videos. This is the OSD and autopilot. It has an airspeed sensor, a GPS sensor, a GPS receiver, a UHF antenna, a UHF receiver, and it does the autopilot and on-screen display functions. The power system for the motor, the speed controller, the step-down voltage regulator, the current sensor for the RVOSD, the FR Sky receiver, short-range receiver, GoPro with a GoPro connector, 2 servos for pan and tilt, and a 5.8 GHz transmitter for the demo. This is the RVLINK UHF repeater for long-range control. So I want to show you how to configure out of the box a brand new RVOSD to set up the controls and to set up the failsafe and the autopilot modes. So in this video we're using 6S configuration, 22 volts, powered directly into the OSD. The BEC is stepping down the voltage for the video transmitter, and it's outputting 12 volts, and the RVOSD is stepping down 5 volts for the GoPro. So the GoPro is being charged. So it will automatically set home position by itself when the signal is strong enough. So home position is set. Altitude has been zeroed out, so now altitude is relative to starting point. Anyway, so this video is about basic configuration. You change the settings in the OSD with the infrared remote. So you push menu to cycle the menus and the screens. I'll just turn the GoPro away. Okay, so the first thing you'll notice is the RX is not detected. This means that the RVOSD has not been properly configured to accept the RX signal. So the first option you want to make sure you have on is going to be the RC receiver connected. Default is no. You want to set it to yes. I'll turn on the Tyrannus.
Welcome to OpenTX.
This Tyrannus V8 series module is already bound to this receiver. So I did this before. And it's connected here using the PPM output. So the combined PPM stream into the RVOSD. And in the RVOSD, it goes into PPM input 1. So the receiver connects PPM stream to PPM 1. And the next step, after you enable that, you should have some controls if you have your servos connected. Be sure to remove the propeller when you do this, and it's better to remove most of your control surfaces in case they are misconfigured and they start binding, because the next step you have to set up your PPM configuration to match your channel to the control output. So if you have, if you start moving the sticks and the throws are incorrectly set, you can overextend the servos. So you would want to go to PPM configuration, which is just under the RX receiver enabled menu, and you push right to get into here. So the way this is set up is you have all of the inputs being read by the RVOSD. So when you move the stick, you should see the value moving in milliseconds. So for example, output 3 is my aileron stick. I can see it moving. So if you're using a flying wing, if you're flying a flying wing, you should disable any mixing in your radio, because the RVOSD will do the flying wing elevon mixing. And now you just need to match your stick to that correct input. So this is how you do it. Throttle, I move it. And by the way, the outputs are disabled to the servos and to the ESC while you're in this menu, so you don't have to worry about the ESC spinning the motor, but you should always remove the propeller during setup for safety. So I'm moving the throttle, so I know this is throttle and it's assigned to throttle, but if it was assigned to something else, you can just change it. So your options are disabled, which means there's going to be no output on output 1, aux 3, auxiliary, elevator, aileron, throttle, rudder, flap, camera pitch, camera roll, camera yaw, gear, lights 1, lights 2, or sorry, lights 2. So I move this, the way you do it is you move the stick, and then you know this is your throttle, so you set throttle. And then you go down, you find out which stick is moving. Okay, this stick, this is my elevator. This is my elevator. So it's set up wrong. I want to change it to elevator. And this is my aileron, so I set that to aileron. My aux 2 is the autopilot auxiliary mode selection switch, so it lets you choose which autopilot mode you are in. I've set this to a 3-position switch, aux 2. Auxiliary is your mode selection switch, so this selects the mode, and this is your function switch, I guess. It's a function, so it lets you enter the menu and engage autopilot while in flight. So this is also a 3-position switch. Those are the only switches that you need to set up to control the autopilot. Two 3-position switches. One to enter the on-screen menu and to enable and disable the autopilot, and the other switch to select the autopilot mode. Output 6 is rudder. Now here's a little trick. So to route your pan and tilt, I use the rudder port. It's a spare in and out channel that I use to route my pan servo. And then for the tilt servo, I use the camera pitch. And the reason I do this is because on the OSD, with the limited number of inputs and outputs, the additional camera ports for pan and tilt are located on the bottom, and you have to solder a wire here. So you can connect your camera, pan and tilt, and even roll here, or you can be clever and use the spare rudder, which I'm not using in this plane. So camera pitch goes here, or it can be camera pan, it doesn't really matter. But you connect one servo to camera pitch, out 5, and the other one to rudder, which is right here, out 4 rudder. So to demonstrate, I have this spare channel on this slider, and it's here, and it's going to the rudder, so I've connected that servo to the rudder output, which is out 4 rudder, and I've connected one of the servos there. Camera pitch is on my other slider, this slider. Camera pitch, it's moving, and the rest you want to disable. If you have duplicates, so if you have auxiliary here and auxiliary here, and this will cause a conflict, and then neither will be working. So you want to make sure that there's no duplicates, the unused channels are disabled. So PPM 1, remember, that's the one we've connected our receiver to, that's the configuration we've done, and it's automatically copied those settings to PPM 3. PPM 3 is your RVLINK receiver, and here is the RVLINK receiver. It's a repeater, so my radio is transmitting to this receiver, and then this signal is being repeated by this UHF, and the receiver is here, so that the same setting. Yeah. We left off the UHF transmitter repeating the long range signal to the onboard UHF receiver, and the Tyrannus is bound to two identical receivers. So one goes in the airplane, the other one is on the ground. It's a redundant system. If you want to go to the field and do short range, you can leave this at home, this whole contraption, and you can just fly with this receiver. Or if the battery dies on your repeater, you can still bring the plane in for landing with this receiver. So it's a redundant system, and the RVOSD automatically switches from RX1 to RX3. So it does the switching internally automatically. So now we've connected all the servos, and we will test. At this point, RC link lost is removed from the screen, and we can test the movement. There's one more setting. So in the menu, you have to, if you're using a flying wing, you have to make sure that your autopilot wing type is set to flying wing. Autopilot output flying wing, and you'll know it's working when you move one stick and two servos move. That means the flying wing option is set. I go up and I see that it's backwards, so that is down, not up. So if I go left, that's correct. If I go right, that's correct, but this is incorrect. So how do I fix that? So I fixed that. If both of the surfaces are going the same direction, but they're going the wrong direction, the way to fix it is to rotate, to inverse the aileron and elevator input physically on the RVOSD. Okay, so go up. Now they're both going up. I go left, I go right, and that's correct. The wind goes down, the wind comes up. That's a right barrel roll. Now, if they were going opposite, like if this was not correct and they were mixed up, there's another option you can change, is elevator, aileron, channel 1 reverse. So I'll demonstrate. I'll do normal. So now I go left, but they both go up. So that's completely wrong. I go back like this and it's working. So the best advice is the advice that I gave before. If they're both going up in the same direction but going the wrong way, then you want to reverse it. If it's going right when it should go left, you should reverse it here. By playing around with those two settings, you can make it work correctly. That's it. So that's set up. You can set your control throws here, your maximum and your minimum and your exponential. That's all done in the radio. So to make it smoother around the center point, to limit the throw, that's done in your radio. So the next thing you can already check to see if it's working is your autopilot. So you can enable fly-by-wire autopilot mode to test the autopilot control throws. And you do that by enabling autopilot by going down on the function key. Enable, disable, disable. So let's enable it, and then you change the mode with this switch. Be sure to have the propeller off, because when you return it home, it will spin up. It should spin up. And now you can move the RVOSD and see how it reacts. I move the RVOSD down, up, down, left, right. So let's say that the airplane, this is the front, that's the rear. So let's say the airplane is pitching up. And the autopilot is also pitching up, but it should be pitching down. So that's reversed. But this is the autopilot output that's reversed, not the control input. This is the actual autopilot output is reversed. If it's going to the right, it's rolling left. If it's going left, it's going right. So that's correct, it's compensating. And that's right. So something is wrong. If I go, this is the back of the autopilot, that's the front. Let me check. Yeah, that's the back. I move the airplane up, and it's also going up. So that's wrong. So to change that, you go into the autopilot menu. It's called the in-flight menu. And here you should have a autopilot output reverse. So pitch, servo direction, reversed. Now to change any modes, you have to disable the autopilot, and then you can change it. So inverted. Let's see if that fixed it. This is still working as usual, but now when I engage the autopilot and I'm pitching the airplane up, the autopilot is moving the servos down. That's correct. When I roll it left, the autopilot is rolling the airplane right. So that's correct. You want to make sure this is working. This is the most important part before you fly, is to make sure the autopilot output is correct and the manual control throughput is correct. Then you save configuration, and that's it. Up, left, right, and then up goes down goes up, left goes right, right goes left. That's working. So the last important step before really you can fly the plane, in the most basic even configuration, you want to set up your failsafe. So if I turn off the radio, nothing happens. But really, if I turn off the radio, it should activate return to home. So to do that, you set the failsafe. Now the failsafe works by detecting a throttle position, a specific throttle position on the throttle channel. So the RVOSD monitors the throttle channel, and if the value goes above a preset point, then it activates return to home. So let's start by going into the Tyrannus throttle control throw right here. We'll be back. Okay, so we left off. We were going to set failsafe position so that the return to home would engage when the signal was lost. So the way you do this is in your radio. First, we're going to be working on the throttle channel, and you set your maximum throttle position to, say, 105%. And now, in the RVOSD menu, there's a setting called failsafe detect, but RC link loss detection. So there's two methods of detecting the loss of an RC signal. A long time ago, I think 5 years ago, receivers used to glitch when the signal was lost, and the RVOSD would use a method called the glitch counter to detect a lost signal. But now, usually you're only using a failsafe position to trigger the detection. So failsafe detect over normal range, and then you set the maximum normal range position. And to do that, you move your throttle all the way up, and you set it. So what I did is I increased throttle to 105%, and then I pushed the arrow to record that value. And now I'll just increase this to 100, anything over 105%, say 110%, and I'll set the failsafe on my receiver and on my RVLINK receiver. So the receivers will go to 110% when they lose signal, and the RVOSD detects a state of link lost anything above 105%. Let's say I push the button to set the failsafe on the receiver. Save configuration. Now when I turn this off, return to home. Okay, and the motor starts spinning, so I turn it on, and it disables return to home. So everything is set up now. I can go and fly, and I know that if I lose signal, the plane will come back. I know the control throttles are working in the correct direction. In flight, you can adjust the gains. Now the gains are set up to work with most airplanes out of the box, and to adjust the gains in flight, if you get oscillations, you enter the in-flight menu by toggling up on the function switch, and then you use your elevator and aileron to navigate the in-flight menu and change the values of the gains. So you just left and right, and you can change the roll gain, the pitch gain, the roll gain. You can adjust the aux autopilot mode, but in our case we're adjusting that with this aux 2 switch, so you can't really change it here. You have to use the aux 2. But if you didn't have aux 2 connected, you could adjust it with the stick. You can in fact change some display settings while in flight. So that's it. You're flying, you're in fly-by-wire mode, and you want to adjust some settings. You go up here. Once you're in the menu, the autopilot will turn on level flight mode. So you're just adjusting the autopilot response to control level flight. So it's easy to adjust, and you can just adjust the roll and pitch gain. You can set the neutral ACHI. So if you want to do that, you have to disable the autopilot first, and then go to set neutral ACHI, and then while you're flying, you align that with the horizon, and it sets the neutral ACHI. You really want to do that while on the ground. It's much simpler to hold the plane and set the neutral position. Another thing you want to do is, once you trim the plane in flight, under manual control you trim the plane to fly level. Then in flight, or after you land, you can go to this section, set neutrals, and engage it, and it'll record your neutral positions. Anytime you trim the plane manually, you want to record that neutral position. For when you're in fly-by-wire mode, the autopilot won't think you're trying to turn. So the fly-by-wire mode actually interprets the stick position as an angle. So this would be left bank up to, I think, 45 degrees. So if your trim is set, then the autopilot will constantly think you're trying to bank. So if you change your trims, then you want to set your neutral positions to match those trims. This is your autopilot settings. This is variable throttle control autopilot. So based on the current reading, current sensor reading, you set a minimum and a maximum watts. You set your cruise speed. This is about 10 kilometers an hour above your stall speed. And the autopilot will intelligently control the throttle to maintain the cruise speed, while also controlling the cruise altitude. And you can set the cruise altitude also in the menu here on the last page, cruise altitude. And that's it. So how to bind the RVLINK. So you see here it's RX1. RX1 is this receiver. RX3, which is not connected, it's not active. That's the RVLINK. So to make the RVLINK work, you have to bind it. And you bind it in this way. You go to transreceiver configuration, and then you set bind main, and you want to set your settings now. So you can change your frequency band depending on the interference in the local area. You can do 430, 440, 450 megahertz. You can set the transmitter power. So I'll just show one tip, and that's how to scan your area to check for the best frequency to use. You can do mode spectrum analyzer, and then you have to enable another setting to see it. Debug screen, transreceiver data. And now you have a spectrum analyzer in your RVOSD, and depending which band you selected, that's the band that's being scanned. Those are the peaks. So that's a pretty big peak. Let's check another band. So sorry, minus 85 was the biggest peak. And then you go to your transreceiver configuration, change the frequency band. Remember, 85 was the biggest peak, 440. Whoa, now 2 peaks at 440. Yeah, it looks the same. So we can change this to 450, 60. The noise floor seems about the same for all of the frequencies, so you want to use 430 because that's the optimal frequency for the maximum power output and the resonance for the antennas. So to bind it, you select bind main, and then you keep this screen on, and on the RVLINK you hold down the bind button with a small pin while powering it on. So we have a power switch here, and we hold down the bind button and we power it on. The power will flash, that means it's in bind mode. So if this is in bind mode and this is in bind main, to apply these settings you simply have to exit this menu. So you hit menu on here to exit the menu, and that's it. It's bound. You can save configuration now. But anyways, now it's working. You have a signal strength indicator here. You can see if I move it far away, the signal strength goes down. If I move it closer, signal strength goes up, depending how I polarize the antenna. So now it's bound. That's it. So the only thing I didn't do is I didn't set the failsafe on this receiver. Maybe it might be set from the previous version. Yeah, so we already set this beforehand. So it goes to return to home.
Welcome to OpenTX.
And I can in fact show another demo. So now it's working from RX1, which is this receiver. If I disconnect this receiver on the count of 3, it's going to switch to RX3. So 1, 2, 3. Now it's on RX3. Connect it again. Now it goes to RX1. So you have a redundant system. And the same thing happens if this disconnects. It'll go eventually to return to home. I think that's it. Every time you change anything in the menu and you want to save the setting, not to apply the setting, but to save it, you have to save configuration. Otherwise, when you power cycle, the setting is lost. Let me see what other options I can. You don't need to set up the RSSI because that's already set up with RVLINK out of the box. You can set up some display options like the display of the turn rate, the variometer. You can do analog and digital display. Analog or digital, you can display the G-force. You can display You can display the ground speed and the air speed, or just the ground speed, or just the air speed. Display the width. Change the width. Like I made it narrow because some goggles crop the display, so you make it a narrow display. But that's it. Those are the basics. So you're flying. You could probably disable the debug screen because you don't need that information. You disable the debug screen in this menu. Debug screen. Disabled. Sorry. That's the GPS debug screen. Disabled. And that's it. To clarify, there's one set of menus, but the menu that's accessible using this switch, the function switch in flight, is only the in-flight menu, because those are the only options you need to change in flight. With the remote, you can access all of the menus. And I can go over the power setup. So we have a 6S power battery. So we set the jumpers here on the RVOSD. There's a jumper called main battery disable. So that disables the high voltage from going and powering the video camera or the video transmitter. So instead we connected a UBEC set to 12 volts to the aux bat, and the aux bat is what's powering the video transmitter. And the camera we set to 5 volts jumper, so the RVOSD converts 22 volts switching regulator to 5 volts. So it's flexible. You can use a high voltage setup, 6S maximum, and you can power everything from one battery and wire everything through the RVOSD. It's a piece of cake. So that's it. Thanks for watching. Old habits die hard. So let me save the settings. That's it. Turn everything off.